Welcome to This Explainer. Today, we're diving into what is honestly a fascinating medical detective story. We're unpacking some newly published research that shows exactly how our daily diet can literally flip internal fire alarms right inside our liver. We're going to look at how metabolic stress triggers these alarms, and, most importantly, how an often overlooked nutrient might just be the key to turning them off.
Here is our roadmap for today's explainer. We'll start with the fatty liver epidemic, meet the cellular alarms, look at a tale of two diets, find the missing nutrient, validate those discoveries, and finish up with the power of choline.
All right, Section 1, the fatty liver epidemic.
To really grasp the gravity of this research, we need to start by asking a kind of shocking question. What hidden, often ignored condition is quietly affecting up to 38% of all adults across the globe right now? You might not feel it at all, but there's a really good chance it's happening inside someone you know.
Yeah, 38%. That is a staggering slice of the global adult population. It's literally an epidemic of massive proportions. But it largely flies under the radar until it reaches a pretty dangerous progressive stage.
And that brings us to MASLD, or metabolic dysfunction-associated steatotic liver disease. According to the research we're analyzing today, this is a progressive condition where excess fat accumulation causes extreme cellular stress. See, this fat buildup in your hepatocytes, your liver cells, doesn't just sit there inert. It actually induces a dangerous cascade of inflammation, recruiting immune cells that act as the primary drivers of liver injury.
Moving on to Section 2, meet the cellular alarms.
Okay, so take a look at these three specific protein complexes, NLRP3, NLRC4, and AIM2. These are canonical inflammasomes. You can basically think of them as your liver's internal fire alarms. As you can see, they have these highly specialized sensor domains, kind of like microscopic tripwires, that are just waiting to pick up on any signs of cellular damage or stress.
Now, when these alarms sense that danger, they don't just quietly register it. No, they assemble into a massive complex and instantly activate an enzyme called caspase-1. That triggers a huge inflammatory response, releasing these really powerful immune cytokines, specifically interleukin-1 beta and interleukin-18. And those cytokines just flood the liver, driving the progression of the disease from simple fat buildup straight into severe inflammation and fibrosis.
Let's dive into Section 3, a tale of two diets. To figure out exactly what pulls these alarm triggers, researchers set up an elegant experimental face-off using mice. Step 1. They fed one group a classic fast food style diet, super high in fat and fructose. Step 2. They fed a second group a specialized diet that deliberately stripped out key nutrients. And step 3, they compared the biological alarms triggered in the liver. Basically, may the worst diet win.
The setup here is actually brilliant. Check out the timelines. The high-fat, high-fructose diet path, labeled HF, had to run for 20 weeks to induce obesity. But the nutrient-deficient diet path, the MCD diet, was so intensely harsh on the liver that it only took 10 weeks to show dramatic results.
Now, here's where it gets really wild. The HF diet does exactly what you'd expect. High sugar, high fat, causing classic weight gain and insulin resistance. But the MCD diet? That one lacks an essential nutrient called choline. And these mice actually lost weight. But internally, they suffered devastating liver injury and advanced fibrosis. So it essentially mimicked a severe form of human liver disease, just entirely without the obesity part.
Which brings us to Section 4, the missing nutrient. So the results of this face-off are absolutely staggering. The fast food diet only triggered one alarm, the NLRP3 inflammasome, which causes a sort of mild low-grade inflammation. But that choline-deficient MCD diet, it unexpectedly tripped all three fire alarms simultaneously. NLRP3, NLRC4, and AIM2 were all activated at once, leading to a massively elevated release of inflammatory cytokines.
It's honestly mind-blowing that starving the liver of a single nutrient causes a much more cellular panic response than just stuffing it with sugar and fat. The fast food diet caused a localized fire, sure. But removing choline from the equation was literally like throwing gasoline on the flames. It caused extreme cellular injury and activated multiple independent danger sensors all at the exact same time.
All right, let's look at Section 5, validating the discoveries. Of course, we have to ask, does this actually apply to humans?
Well, the researchers answered that by looking at biopsy data from 20 human MASLD patients and comparing them to healthy livers. And the data is crystal clear. The exact same elevated alarm bells are ringing loudly in humans. Patients showed significantly elevated levels of the NLRP3 alarm, the Cas-PACE1 trigger, and the resulting inflammatory cytokines. This definitively proves we're looking at a very real human problem, not just some laboratory curiosity.
And finally, Section 6, the power of choline.
To prove the protective power of this missing nutrient, researchers set up an in vitro co-culture, combining liver and immune cells. They bombarded them with fatty acids and fructose, which, as expected, immediately spiked those inflammatory alarms. But when they added choline back into the mix, it acted like a chemical shield. It completely blocked the inflammatory alarms and drastically reduced those harmful cytokine levels, even while the dangerous fatty acids were still right there in the environment. Which leads us to an incredibly hopeful conclusion directly from the source material. The researchers state clearly, choline supplementation may represent a nutritional strategy to mitigate inflammation in MASLD. So it turns out that making sure we have enough choline in our system isn't just about covering our basic nutritional bases, it's a really powerful, active strategy to protect our liver from the daily metabolic stress we throw at it.
So I'm going to leave you with this final thought to ponder based on everything we've unpacked today. Knowing how incredibly sensitive your liver's internal alarms are, is your current diet quietly sounding the fire alarm, or is it actively building a cellular shield? The choice is entirely up to you. Thanks for joining me for this explainer, and I'll catch you next time.